So taking a look at number 26, something kind of sneaky happens here. So I wanted to make this video to illustrate that point. So right away, we take out the greatest common factor. We have two terms. What is common to both terms? Cotangent theta. So I take that out to the front. So if I divide away cotangent from the first piece, I'd be left with cosine. If I take away cotangent, if I divide cotangent away from cotangent, I'm left with a positive 1. That 1 could have been seen right there as the coefficient. Now, zero product property. This times this equals 0. Then perhaps this piece is 0. Perhaps the second piece is 0. Or perhaps they're both 0. So now we have two separate equations. Let's solve this one first. Subtract the 1 to the other side. Let's solve this equation. Cosine of theta equals -1. Remember that cosine is the x-coordinate. And we want the x-coordinate to be -1. Where theta is an angle. Where, at which angle, is the x-coordinate -1? So you look at your unit circle. X-coordinates being -1. That only happens here. And at this point. And this point is along this angle. So I think they wanted radians. So it'd be pi radians. So this theta has to be pi radians. So from this equation, we discover that one of the answers is pi. Now over here, let's look at this equation. We can view cotangent as, amongst the many things that cotangent could be viewed as, it could be viewed as x over y. So this here, cotangent, is like x over y. The goal is theta, but let's just look at x over y. So this is a fraction, and this fraction equals 0. So the implication is that x must equal 0, right? If you have a fraction which happens to equal 0, the implication is that the numerator is 0. So find angles theta where there's a point where the x-coordinate is 0. Well, where do we have x-coordinates of 0? Here and there. And that's pi over 2 and 3 pi over 2. So we have pi over 2 and 3 pi over 2. So you would think that your solution set would be pi, 3 pi over 2. And you would think that this is the answer because you combine all three of the answers and turn it in. But it turns out that this here, that's an extraneous solution. And I'll tell you why. Because an extraneous solution is a solution that you get that actually doesn't work in the original equation. And the reason that that pi is no good is because this pi, it cannot be plugged in there. And I'll tell you why it's no good. Think of what's cotangent of pi? Cotangent of pi. So what we're saying is that this is no good because you cannot plug it in there. Because we cannot have cotangent of pi. I'll tell you why cotangent of pi is no good. What do you know cotangent to equal? Cotangent, amongst the many things that it is, right here it says cotangent could be looked at as 1 over tangent. So look, cotangent of pi is the same as 1 over tangent of pi. And this is the same as 1 over. Well, let's see. On a calculator, if you type in the tangent of pi, make sure your calculator is set to radians. If you type in the tangent of pi, if you hit enter, look, it says 0. So this is the same as 1 divided by 0. But 1 divided by 0 is undefined, right? We cannot divide by 0. So 1 over 0 is the same as 1 over tangent of pi, which is the same as cotangent of pi, which is what you get when you plug in pi, and that's bad. So pi leads to 1 over 0, which is undefined. So for that reason, this answer is no good, and the only solutions would be these two right there.